the graphics are not completely great on these. Great for Minecraft, because Minecraft is 8-bit square stuff anyway, so it doesn't really matter. Slow data transfer, they tend to be a little bit slow, so if you're trying to use these for, like I said, if you're gonna use this as a web server, you're not gonna want to serve up Amazon.com on it. But if you have a small site that doesn't have a lot of images and a lot of different things you need to do with it, that's good. The Pi 4, however, what we just talked about is kind of minimizing the cons. As they continue to develop these, again, with Moore's Law, in effect, we can put more and more in the smaller and smaller space, which means if we're going to use the same space, we can do more with it, right? So the Pi 4 is starting to minimize the cons, but those still exist. So now we're going to go switch gears and talk about the hard drive. So again, you have the comparison of the hard drive with this guy's hard drive. So actually, the part that you plug into, so this is an adapter that lets us plug it into a desktop computer. This is actually the hard drive. Okay, this is the SDHC card. All right, and this micro SDHC card is what plugs into the Pi that gives it its capacity to store an operating system and have applications and store data and stuff like that. This card actually is 16 gigabytes in size. You can buy these up to 64, I think, maybe even 128. So you can fit a lot of stuff into a small compact space. These are fragile. They can be broken. I have done this before. Trying to pull one out of a Pi and snap. It snapped right in half. So they are a little bit fragile, and if I had that one, I would have brought it in, but I don't have it anymore. So you can see the difference, you know, quite a difference in size. But this is how the Raspberry Pi is able to store things. So it's an SDHC, stands for Secure Digital High Capacity Card. And again, oftentimes these have an adapter in them, so you can plug that in. You can then put that into a regular desktop or a laptop computer. They have limited writes and stores, so there's only so many times you can write and read from those cards. So eventually they will go bad. But that's one of the drawbacks to them. They're limited writes, but they are compact. I already said they're fragile. They are waterproof, and they're a little bit slower compared to other things that you could plug in. Even to a USB drive, they would be a little bit slower, possibly, than that. And then we'll talk a little bit about how you put an image on here, although it's not something you're going to be doing. In Linux, there's a utility called disks. In Windows, there's Win32 Disk Imager, and in Mac, there's a disk utility. Have anybody ever ventured into the disk utility on a Mac or any of these in any places? So one person's nodding their head. So those are the utilities that basically let you work with disks and let you format them to different formats. In order to use a disk in any operating system, you have to format it so that it can be read to and written from, and written to in that particular operating system. In Linux, how many of you have actually used Linux or even know what Linux is? Just a few. Linux is an operating system that is a derivative of something called Unix, and Unix is basically a text-based command line operating system. So these ones you boot into, and in Windows and Mac you have a nice graphical interface. You have the mouse you can do things with. Everything that you do with the graphical interface on that actually has an underlying command line command that goes with it. All right. So even though you don't see what that is, everything you do has that equivalence. Unix was developed as an actual true multi-user operating system. So back in the 60s, you used to have these huge supercomputers, these huge mainframes computers that would take up about the size of this room, possibly. And everybody would have a terminal that would connect into that computer. Okay? And Unix was developed for those kinds of things. And those terminals, obviously, back in the 60s, didn't have great graphics capabilities. It was basically maybe a green screen with you just had text. You could just, a command line, and it was waiting for you to type a command for you to do something. And so Linux is a derivative of that. And so a lot of people that use Linux, basically computer nerds like me, will basically use that through a terminal most of the time as well, since it's a derivative of that. Linux, however, does have a graphical component as well that's built on top of the command line interface. And so these computers here actually do dual boot into Windows and Linux. The Linux side of that actually does have a graphical, you can log in and you can use the mouse and you can do things in a graphical environment a lot like you do with Windows. But there is the real power of Linux is in being able to run commands at the command line and have multiple users signed in at one time on a computer. So that's really the advantage of that. There's a utility in there called DD, which I think stands for disk duplicator on the Linux side. And I don't know if we need to talk too much about all this. You're not going to be doing this, but this is an example of something that might be going on behind the scenes while you're if you go into any of those disk utility things in Mac or in Windows or whatever, and you're doing that kind of stuff. This is an example of what might be going on behind the scenes as you do that. So again, this is a command line utility. Okay, this works on Linux and Mac. Interesting side note is I talked about Unix before. Unix is the grandfather of almost every operating system that we have today, except for one. Anybody know which one? It's the most popular one. Well, maybe not among college students. Windows. Windows is the only operating system that does not have Unix as its sort of grandfather. Okay, Bill Gates created Windows from an operating system that he had created before called MS-DOS. MS-DOS was his command line operating system, a lot like Unix, but it was developed for an entirely different purpose. It wasn't necessarily developed for a multi-user environment for those mainframes. It was specifically developed when personal computers were first becoming a thing, right? Used to be we couldn't have all these computers here. You only had mainframes. So Bill Gates developed MS-DOS as an operating system for that. And so that was at first just command line based. Then Windows came on the scene. At first it was built on top of it, then it became its own thing. So it is the only operating system that doesn't have Unix. Even Android, I have a Pixel, so it's got Google's version of Android. But the Android operating system on here is a derivative of Linux. Okay, it's actually Linux that you're running, even though you didn't know that. And Linux is a direct descendant of Unix. So even your smartphones have operating systems, and iOS as well. Same thing, Mac OS, iOS. So when I say that, I kind of got off on the tangent because I said this works with Linux and Mac because those are Unix derivatives. And so DD is a command that came all the way from the Unix days. All right, so it still exists. The Macs that you have also have sort of Unix, a version of Unix as its underlying operating system, even though you would never really know it unless you got really down deep into the guts of it and start doing things on the terminal command line, but that's basically what has Unix underpinnings. So anyway, imaging Raspbian, it's now called Raspi OS, I think. I don't think they call it Raspbian anymore. Raspbian is the operating system for the Raspberry Pi. So much like Windows is an operating system that lets you do things on PCs, and Mac OS is the operating system that lets you work with Macs, Android, and so on. Raspbian is the operating system, and it is also a Linux derivative. So it is sort of what we have different, what I like to call flavors of Linux. And so it's one of the flavors of Linux that you can use. And so this is sort of an interesting example of a command line thing that you would say, because DD is actual command that you're running, okay, and these are spaces. So after this, you have different parameters that you're giving the command to tell it to do certain things, or you're defining certain things about that. So the first thing you're doing is you're saying byte size, and what that's basically saying is you're going to, this is 1 megabyte, So you're gonna copy one thing to another, and you're gonna do it in 1 megabyte increments. Okay, that's basically what that means. And the next part is input file. So the input file is this file name right here. Okay, so it could be a .image or a .iso. Those are what we call image files. So you can take an entire operating system like Raspbian and put it into a one image file, and that image file can then be copied to another device in order to be able to boot your Raspberry Pi. And the OF is the output file. So in Linux world, this is actually a disk, okay? And this disk, in this instance, would likely represent, what did I do with my, here it is, represent this, probably, okay? So dev SDC, you don't have to really know what that means, but in the Linux world, dev stands for devices, and then each one of these, each device has its own name once it gets connected to the system. So dev SDC might be something like this. So what that's basically saying is, I want to duplicate at this rate this file out into that disk. Okay, I know that's might be really confusing. You probably don't really have to remember that, but if I were to be in a graphical environment, I might say, oh, it might present to me, okay, what file do you want to use? I have to go look up that file. I use my mouse. I look up where that is, and where do you want to copy to? I want to do it over here. And you do that all in a graphical environment, and you don't have to remember how to format this command or what the syntax of this command is. The graphical environment does all that for you. But this might be an example of something that might be happening behind the scenes when you do that. Right? When you click OK in the graphical environment, it actually runs this command. Okay. So, yeah, one important thing when you work with command line things, don't mess up the order or you'll destroy something. So if I accidentally said IF of this and OF of this, it would go backwards and it would copy everything that's already on this drive into this image, and I would destroy my image. Okay, so when you're working with command line, you do have to be careful about certain things as well. So tomorrow, or not tomorrow, Friday, what we're going to work with, and I already pass it around, but we're going to work with these Pis here, and what we're going to be doing is we're going to be hooking in keyboards and mice to these, and we're going to be hooking these up to monitors up in room 217 upstairs. So we're going to be working with these. They're already going to have the cameras installed in them, so because we have limited time, we're not going to make you install the hardware and all that. We would normally do that, but we're going to be nice to you and do it for you. These will have a power supply that will connect to them. So this is an example of the power supply that will come with it. This is a micro USB power supply. So we have a power supply. We have the Raspberry Pi 3B Plus. That's what model this is. The SD cards will be pre-formatted. And the SD cards, there's actually a place right down here those SD cards plug into. They'll already be in there for you. And the camera with the ribbon cable, already talked about. And what we're going to do is we're going to set up the Pi to use motion. So we're going to hopefully by the end of the class period get this set up to where you'll be able to grab an image from this camera, and you'll be able to set it up so that when motion happens, it will take a burst of pictures. Okay, so this is sort of an example of something you could, I talked about home automation, it could be home security as well. So if you had something like this, it doesn't have to be in a case like this, but if you were able to, there are already cases made for this where you can take this camera and you can actually have it sitting inside a case where you can actually set up a little home security system. And in fact, one of our former professors here did this. This is what kind of inspired the project that we are going to do on Friday. And that he programmed his to, anytime he lives out in the country, and every time it would sense motion, it would take pictures, and it would send those pictures to him over the internet so he could see what was going on at home. Right? So a really simplistic sort of home security kind of device to be able to do that with. So hopefully by the end of the day, we're going to have our Pi set up to be able to, first of all, grab an image from this camera, and second of all, hopefully be able to get to the point where it can do a little bit of motion as well. Okay. So this is a project that we have done in the past with 24 at Taylor for prospective students. We let them take this stuff home with them. We're not going to let you take it home with you, sorry. But that's why we have these nice cases that say Taylor University, although this one doesn't say that, but some of them do. So I think that's just about all I've got. Any questions about any of this? Anything at all? Or observations? Everybody's tired after lunch, right? So hopefully it gives you a little bit of an introduction to what these things are and why they exist and why they might be useful. A little bit more about about the computer itself and how it kind of works under the hood. And if there's nothing, you have anything else you need for them? I think we're good to go. We're a couple minutes early, so enjoy.